Morning. We're looking at the homework packet that was from last week. We're on the first page, but we really have questions about the second page. Okay, so first box and whisker, I bring that over here. Determine whether or not there are any outliers. In order to determine whether there are any outliers or not, I need to find the upper and lower fence. And I think that makes sense maybe in people's head a little more if we look at part of the box and whisker. Here was Q1 at 101. Here was Q3 at 121. Okay, and IQR is how far apart is it from one edge to the other edge of the box in the box and whisker plot. What you're going to look for is an upper fence and a lower fence to decide if there's outliers. What the upper fence and lower fence is 1.5 times the IQR added on this side and 1.5 times the IQR subtracted on that side. So 1.5, the IQR is 30. 1.5 of 20 is 30. So 121 plus 30 is 151. 100 minus 30, okay, backing it off, is going to be 71. Okay, so this is lower fence, upper fence, and people were starting, from what I could see last week, to get the hang of understanding that. So now the question really is, are there outliers? Are there any numbers above or beyond that? Okay, so I know you're looking at this. Can I flip back? I gotta look. Oh yeah. So on our first original box and whisker, here's 151 and here's 71. Okay, so there's a tiny bit below. I know the min is 69, and that's below the 71, less than the lower fence. That's an outlier. Okay, now 151, I can see definitely the max is over 151. Let's see if there's any other. This is bigger than 151, and that must be it. So this 181, the min and max are both outside of that range. They drag the spread out in two directions, but we call them outliers. They're way far out of bounds of what the rest of the data is. Okay, so I come back over here, and this was it. Determine whether or not there are any outliers. Show your work. So what was it? 181 is an outlier, and 69 is an outlier. And I kind of showed my work graphically. You could have showed it numerically by calculating the upper and lower fence. Reconstruct the box and whisker plot to show any outliers. Reconstruct to show. What do they want us to do? Normally they have us reconstruct without the outliers. I'm trying to understand this to show. But guess what? I've got a key, so we'll make sure we're doing it right. I think they probably want us to get rid of that 181 and 169, but I don't want to teach you wrong. Oh, this is not in the book. Hold on a minute. Assignment. And Carnegie, Chapter 8. Page 104. Oh, that's the wrong one. Come on, wake up. There we go. 104. Oh, I bet I could just type it in up here. Oh no, that won't work. There we go. Okay. So what they do is reconstruct it without the outliers and put little stars where the outliers are. So here's how we're going to help ourselves do it. Okay, I go back to my list, stat, edit, and I scroll through the list and see that 81. I'm going to push delete. Goodbye to 81. You can see how it just collapsed the list on down. Now I got to find that 69. There it is. I get my cursor so it's on 69, and I'm going to delete it out of my list. Now my list has fewer things, and I'm going to redo my 5-number summary. So stat, calc, 1 variable statistics. I'm still in list 1, but it's a slightly different list 1. Have to scroll down. Now if I just look at the core of the data without those 2 outliers, I have a new min, max, median, etc. But I'm going to need to number it the same way. I'm smarter at putting them a little closer together. Okay. Now, my new min is 82. My Q1 is 101. Median 108. Q3 120. See how much closer together that box has got? And max is 128. So without the 2 outliers, a big, whoops, I don't need that line. I need lines right here and right here. Without the 2 outliers, the data goes whoop. It's a lot less spread out. They did want us to show there used to be a 69, and that was right here. And there used to be a 181, and that was right there. So this is the reconstructed data plot, or box and whisker, showing the 2 outliers, but showing what the rest of the data would look like without it. Okay, that was C and D for number 1. Other questions? Alrighty then, make sure your name is on it, please. Send 1 person from each table up with your lessons. I have tests for people who were not here on Friday. Wyatt, Martine, Kenya, Jacqueline. You will need a calculator if you don't have one. Do you want to get the calculator, Wyatt? And then take it on off over there somewhere. Thank you. Chris V.
Huh?
Apex today.
Oh. I'll get something tonight.
What?
I'll get something tonight.
Well, why don't you come today and I can get you going so we can get started, figure out how to do it.
Okay.
Right here, I got one. A present for you. Yes, you may. Take the pass. Okay. So now, we need rulers.
Sit down.
All right. We're starting a new unit, but before we move into what we're doing, we're going to review linear functions.
Yeah.
What does something mean if it's linear?
Straight line.
Straight line. So we're going to be looking at a new step in linear functions in chapter 9 called linear regression, but we're going to review before we do that what we already know. So let me pass this out. We'll be going on it together. These chairs are hard, huh? They'll be back. Or you can sit still. Oh, good. We don't want you to be sad. Oh, I wonder how Ruby's math is. Some tells me Ruby's math is pretty good, huh? Okay, first thing to remember about linear equations is slope. Slope. Raise your hand if you know how to do this. Y2 minus Y1, I'm hearing that out there. Here we go. Maybe I'll put it up top, actually. Y2 minus Y1 over. Okay, this is important. Now, another thing that's important is remembering who's X and who's Y. Andy, could you bring that to me, please? Okay, if I'm looking at an ordered pair, who's X and who's Y?
First one is X.
They're in alphabetical order, yes? X, Y. X1. Okay, if you can remember this and that, you've got it made, yes? It's subtraction, actually. We do have some trouble with positive and negative numbers from time to time, but I'm way over to the side. Here we go. Keep up, keep up. Are you with me? 8 minus 4 and 3 minus 2. Both of them starting with this number and subtracting the other ordered pair. 8 minus 4, Oscar.
4.
Thank you. 3 minus 2.
1.
Oh, good. I know it's Monday. There we go. Slope number 1. Okay. Number 2 has a negative. Again, I warned you, sometimes negatives are tricky. 6 minus 4, this number minus that number. So far, not so bad. And now here's where comes the trick. 1 minus a negative 1.
Does it become positive?
It becomes a positive, but before it does, in your head, and most of you should write it down, don't forget you're always 1 minus a negative. So you end up adding. Okay? But you got to carefully not lose a piece of that. Okay, so here we go. We've got 2 over 2. You guys do number 3. I'm walking around. One time I looked and they could talk and hear on play. Appear to be functioning at this end. And I see a little green light up there.
It's just they don't want to look at it.
That could be. Oscar, guess what? Your buddy's back.
Oh.
Come on over. So now I think he's lonely.
Do we go on?
Well, let's see. Let's make sure we're on the same page. Because again, negatives give people issues. -6 minus a -3. Look at all of those negatives. 1 minus a -2. First of all, memo. -6 in front, subtracting -3 in back. 2 subtracts makes a plus. What's -6 plus +3?
Genius.
And then again, +1, subtracting -2. That's what we have. 2 negatives becomes a plus. You're over a 3. That reduces.
-1.
-1. 3 divided by 3. We're dividing. It would be 0 if we were adding, but we're dividing. All right, flip the page. I remember this problem from back in the beginning of the year. Ernesto might need one of these. There you go. EW Light Company charges their customers. Put a box around this at the top. $0.14 or 14 cents per kilowatt hour used. The EW company sends the customers their bills monthly. Identify the independent and dependent variable. EW Light Company charges for kilowatt hours. Anybody know what kilowatt hours measures? Energy. Electricity. Usually that's how you pay for electricity. So, independent, dependent. If somebody's charging you for something, what?
Well, I got
You got it?
Independent is the time, and the dependent is the price.
Wait, you say it again?
The independent is the time.
Time or kilowatt hours, which is we'll call it time. It's kind of time.
And the dependent is the bill.
Is the bill or the cost. Okay, so dependent is cost measured in dollars, and this one it's more than time. It's the electricity used in that amount of time. Okay, and again, unless you pay an electric bill, you wouldn't know this. Even actually, Mr. Marwick doesn't know this. Well, I pay the electric bill, so he'd just be like, just pay it. I don't care. No. Here we go. So we'll call it energy per hour. Okay? And it's in kilowatts. Hours. It's kind of a complicated little feature, but basically it's how much electricity are you using. All right, 14 cents an hour. If we use 0, how much do we have to pay them? 0. If we use 1,000, we got to time. 1,000. Two people are saying different things. So 1,000 times 0.14 equals 140. I'm off?
No.
0.14 is how many dollars? So 140 is somebody's electric bill for that month. Okay? 1,200, 1,200 times 0.14, 168. My electric bill for January, well, it's actually electric and gas, was over 300. I didn't like opening that one. It's always bad in December, January. A lot of it was the heater. It was so darn cold. Go ahead, finish filling in that table,
Wait,
please.
do you put a lot of Christmas lights up for Christmas? You seem like a person.
I usually do, but I have a kid in college, so I try to cut back on frivolous
She's
expenses.
just so joyous all the
I
time.
do. I really go crazy on holidays. In fact, my frosted Valentine cookies yesterday. I love holidays. But,
Yours is just a year other day.
I know, there's a lot of pressure about Valentine's Day, but I spread love all over the place.
Halloween. I got raisins.
You're allowed to have your opinion.
Okay, you got a calculator? There you are. Times in the numbers by 0.14, alright? So that's what we gave us at the top.
That's like hard.
Here's Sharon.
Or you know
Okay, looks like you guys are on it. Anna, could you help me out? What are these numbers?
196, 224, 252, 280.
Okay, so putting dollars in there, you don't have to, but I think it's helpful to remember what we're talking about. We're talking about an energy bill. X 0.14 times X. Oops, and I wrote a 5. Flip the page. You ready? Calculate the unit rate of change between the different pairs of points. What do you notice? Now, unit rate of change. Oh, Derek, on it, yes.
Every 200 kilowatt used, it goes up by. Every 100, it goes up by 14.
Okay, so every 100 it goes up by 14. We usually put the dependent variable on top and the independent variable on the bottom. So dependent variables are money, and so here's what we're going to have. You said 14 for every 100. Is that what I heard Jerry say? How'd you get that, first off, Jerry?
Because I looked at the graph and I noticed that they go up by 200 and the price goes up by 28. So I don't have to.
Okay, see this? He looked at these as going up by 200 each, and those as going up by 28. So that's how Jerry came up with the 100 for 14. Okay, dividing both by 2. Did you get one of these, Kenya? Good. Okay, so we could have done 28 over 200, or 14 over 100, or,
7 over 50.
yeah, but what's 14 over 100 in decimal form?
0.14.
Ah, that looks familiar, yes? Okay. Consider the function in the form of C of x to describe the cost in using x kilowatt hours. Write the function. What function family? So they want us to go C of x equals. What did we say was happening for every amount of electricity used?
Is it 0.14x?
0.14x. We already kind of had that relationship on the front of the page. We're just using function notation. What function family does this represent? Linear. If you have an x that does not have exponents, it's linear. Linear. Just a plain old x, linear. Use the function to create a graph representing the change in the cost as a function. Okay, so I'm going to have to flip back and forth a little bit. Sorry about this. Oh, no I don't. I can just, they're facing pages. So, at 0, 0, we have a dot. At 1,000, we're at 140. Now, oh wait, maybe we should label our axes. What do we have? What are these big numbers along the bottom?
Watts. Energy.
Energy measured in kilowatt hours. You both were right. And then what do we have along the vertical axis?
Cost.
Cost. Right here, Wyatt. Measured in dollars. Okay, 0, 0. Next one is 1,000 in kilowatt hours and 140 in dollars. So here's 150. I'm going to go a little bit down from 150. Next one is 1,200. Let's see, if this is 1,000 and this is 1,500. And that's 500. 1,200 is going to be right about on this line, but they didn't give us nice units to help us with that. 1,200 and the cost is 168. Go up, go up, go up. There's 150. I'm going to estimate this is 168. Then 1,400. 1,400 is going to be close to the 1,500, and it is 196. So I'm going to back off from 1,500 a little bit and go up to 196, and that's going to be a little below 200. All right? Keep going, making your dots.